So let's say you're in a grocery store, completely empty, nobody in it. And a strange man walks up to you and asks you to find the slope of a tangent line along each point of a curved graph. Now, I'm going to tell you how to not fear this man in the grocery store and find the derivative function. So first of all, I think it's easy, right? I've only been doing this for a couple weeks. I think it's good. Now, the first thing I'm going to talk about is the definition of the derivative called the difference quotient. According to the Web of Science textbook, the difference quotient is f of x minus f of x plus h over over x plus h minus x. Now, x is canceled out on the bottom, you're left with h. Now, on the top, the x should cancel with the x when you plug in your functions, and then you're left with only things that have factor h in them. Now, you cancel out the h in the bottom with the h's in the top, and you're left with a single function. Now, I'm going to introduce something called the limit, and the limit is as h approaches 0. We don't care what happens when it approaches 0. We care that it becomes infinitesimally small, such that it can no longer affect x. And now x is essentially its own component. This is done by what's called direct substitution, where you can then put it into a function and it just equals whatever h approaches. And in this case, it's 0. And the next point I'm going to talk about is the derivative rules. Now, the derivative rules are a set of large rules as defined by the Web of Science textbook. And this is the reference page. Very long, very tedious, lots of them. There are a total of 36 total of them. And today we're going to focus on 3. What are called the power rule, product rule, and quotient rule. Now, the power rule, so you have x squared. Now, when you take the derivative, you subtract 1 out of the top, and then you take the 2 and you multiply it out front. So x squared becomes 2x to the first. Subtract 1, put it out in front. And so we can use this in the product rule. So the product rule states that if you have a function and you're multiplying 2 things together and you're trying to find the derivative, you take the first thing times the derivative of the second thing plus the derivative of the first times the second untouched. Now, the quotient rule is a little more complicated, and it's when you have 2 things, top and bottom, and now you're going to take the bottom, you're going to square it, and you're going to take the top, you're going to take your denominator times the numerator derivative minus the top times the denominator derivative. It's the quotient rule. Now I've talked about the rules and the definition. Now I'm going to talk about the related rates. Related rates is a concept that continues to confuse me to this day, even though I've been doing it for a couple weeks now. And it gives me a lot of trouble. So, essentially related rates, you have 2 things traveling in different directions, and you're trying to find the slope of the secant line between those 2 points. So like you say you have 2 planes moving away from each other, one west, one south. One going west is 200 miles an hour, one going south is 350 miles an hour. Now, what happens 2 hours later? What is the slope of this line? And that's essentially what you're finding. And you can take the derivative of your original function, plug in the numbers you know, and you find the derivative of this slope. You can also use your standard slope formula for this kind of same related rates, and it helps out a lot. So I've talked about the difference quotient and the definition of the derivative, the rules with the power, quotient, and product rules, and I've talked about the related rates with like 2 planes moving away from each other. Now, I've only been doing calculus for a couple weeks. I enjoy it. And an interesting statistic, actually, even though calculus is considered a high-level form of math, it's still considered easier than statistics according to a lot of students. So I think you should take it so that you don't have to fear the scary man in the grocery store.